Hi everyone. I wanted to walk you through some examples of areas of similar figures because this topic can throw people off a little bit. You have to be very careful reading the questions and very careful understanding when things are growing or shrinking, whether you're talking about side lengths or areas. So here we go. In level 1 of this type of question, well, really in all of the levels, you want to start out by thinking about things as this value r is going to be the ratio of lengths, the ratio that the lengths are in compared to each other, and r squared is going to be the ratio of the areas. Now, in this first question, it says the sides of these two similar figures are 4 and 2. Those are lengths. And we are looking for the area of the smaller square. So since we know the lengths, we can make the ratio of the small square to the big square. It would be 2 to 4. Or we could rewrite this as a fraction. We could say that it's 2 over 4 as 2 to 4, and that reduces to 1/2. So you notice right away that 2 is half of 4, and the ratio of side lengths is going to be this r value, 1/2. So when we want to figure out the area of the smaller square, first we want to figure out the ratio of the areas, r squared. So r squared down here is going to be 1/2 times 1/2. That's 1/4. And now we know that the small square is 1/4 the size in area of the large square. So we could do 16 square feet times 1/4, and we would be finding that it's 4 square feet for our answer. Because 4 is 1/4 of the size of the original 16. Notice that it's not half the size in terms of area. It's 1/4 of the size in terms of area. Let's go on to level 2. So in this level 2 question, it says, what is the ratio of the area of the smaller circle to the area of the larger circle? So it's a lot like our previous question. We want to start out thinking about what r equals, find what r squared equals. So in this one, we can see that the r value, the ratio of the lengths of sides, is going to be 2 to 6. 2 to 6, which translates into a fraction of 2 over 6, or 1/3. So we would say that the diameter of the smaller circle is 1/3 of the size of the diameter of the large circle. Now, in the question, though, we're interested in our answer being about areas. So we need to find r squared to see how the areas are related. Well, r squared is just going to be 1/3 times 1/3, which is 1/9. So they're related in terms of a ratio of 1 to 9. Now I just want to check, this question said the ratio of the area of the smaller circle to the area of the larger circle. And so I have a ratio of 1 to 9. Notice I am doing smaller circle to larger circle. So that's the correct order for my answer. If the question had said the ratio of the larger circle to the smaller circle, I would have to switch this around and be careful with the way that I answered my question. So here's level 3. The figures below are similar. The labeled sides are corresponding to each other. We have 5 millimeters and 1 millimeter. What is the ratio of the area of the larger rectangle to the area of the smaller rectangle? So this time, we want to again look at r and then r squared, but we want to be careful with the order that we set up our ratios in. We want to end up saying the larger rectangle first in this one. So when I look at the lengths, I'm going to say that the ratio of lengths is 5 to 1, or 5 over 1. That makes the ratio of the areas 5 over 1 times 5 over 1, which is 25 over 1, or 25 to 1, when written as a ratio separated by a colon. So our answer is going to be 25 to 1, because we wanted the larger rectangle area first and the smaller rectangle area second. So we are in a ratio of 25 being larger to 1. Level 4. In this shape, you'll notice that we're given the areas of the figure. So we want to set up r and r squared and ask ourselves, which one do we start out being able to find? Well, actually, it's r squared, because that's the ratio of the areas. Now, at the end, it says we want the side length of the smaller pentagon to the side length of the larger pentagon. Well, that's going to be the ratio that we get for r. So if we start down here with our r squared, but we do it in this order, the smaller side, because it says we want to start with the small side of the pentagon, then the larger side next, we would go with the smaller one first, the larger one second. So we'll say our ratio is 49 to 81. As a fraction, this is 49 on top, 49 to 81. So now we need to go backwards and figure out what the r ratio is if we already know the r squared ratio. So this time we're going to take the square root of both numbers in our fraction. The square root of 49 is 7, and the square root of 81 is 9. So we have a ratio of side lengths is going to be 7 to 9. And then I just want to check, did we really do the smaller first and the larger second? Well, we do have the smaller number first and the larger number second. So it does work out for an answer. 7 to 9 is the ratio of the lengths of the sides, even though 49 to 81 was the ratio of the areas. Now, our top level question in this section looks something like this. The figures below are similar again. The area of each figure is given. Well, we're familiar with that. We can get r squared is 72 over 8, which that fraction will just reduce to 9 over 1. So we can work backwards and say if r squared is 9 over 1, the square root of that is 3 over 1, or a ratio of 3 to 1. Now we just want to check what the ending question says to make sure that we have things in the right order. What is the ratio of the side length of the larger rectangle to the side length of the smaller rectangle? So the important thing here is we're starting with larger to smaller. So when we look at our ratio that was our answer, 3 to 1, it is larger to smaller. And it is the side lengths that we're working with. They gave us how the areas operate, and we figured out how the side lengths operate. So the overall idea of this is that r is the ratio of the lengths of the figures, and r squared is the ratio of the areas. And you need to keep those ideas separate and be careful about when something is the smaller side or the larger side, the smaller area or the larger area. Keep everything in the correct order according to the question.